BBoying, aka breakdancing, is a form of street dance that originated in New York City. With 4 movements consisting of top rock, down rock, power moves, and freezes, it has quickly become one of the most popular forms of dance shown in modern media and is performed all around the world. So what does BBoying have to do with physics? Well, everything. BBoying requires a lot of physics in order for those B-boys to perform all those crazy dance moves. So I guess you can say that B-boys are actually physicists who don't actually know that they're physicists. So let's see how these dancers are using physics. First, let's look at Newton's first law. An object will stay at rest or in uniform motion unless acted upon by an external force. This is true in B-boying. Say a B-boy does a head spin. According to Newton's first law, he or she would be spinning on their head forever, but due to the force of friction on their head and the ground, they will eventually decelerate and stop. Newton's third law states that for every action there's an equal and opposite reaction. A b-boy decides to do an air flare. He pushes the ground in order to propel himself upward to do the air flare. At the same time, the ground pushes on the b-boy. Now, time to look at Newton's second law. Force equals mass times acceleration. For this, we're going to look at centripetal force. What is centripetal force? Centripetal force is a force that makes a body follow a curved path. The direction of it is always orthogonal to the velocity of the body and towards a fixed point of the instantaneous center of the curvature of the path. The formula is force equals mass times acceleration, or mass times velocity squared divided by radius. The acceleration is centripetal acceleration. Okay, so let's look at this video of B-boy Seiko performing a 1990, which is a move where a person spins on one hand. To find centripetal force, we're going to need a few pieces of information: his radius, his tangential velocity, and his mass. Now, to find the radius of his movements, we first need to take his height. That is about 6'2", or 1.88 meters. Then you take 1/4 of that, which is about the length of your foot to your knee. This means his radius is approximately 0.47 meters. To find his tangential velocity, we'll take his revolutions per minute, which is 120 RPM, multiply that by his radius, and 0.10472. Seiko's tangential velocity is approximately 6.0 meters per second. In his size and frame, his weight would be 81 kilograms. Now we'll use our formula and multiply our mass times our velocity squared and divide it by a radius to find our force to come out to be 6,204.255 newtons. Conservation of momentum and conservation of energy also play some big parts in b-boying. A b-boy does a backflip off of his buddy's back and is brought to rest as a result. For conservation of energy, if a b-boy goes from his top rock to his power moves such as a windmill to a freeze, the amount of energy stays constant. The amount of energy doesn't change, it is just transferred. This is true even during moves. If a b-boy does an air flare, then his gravitational potential energy increases when he is in the air, and his kinetic energy decreases as he is falling to the ground. His kinetic energy increases while his gravitational potential energy decreases as well. We'll look at exactly how energy plays a role in b-boying. We'll take b-boy Clover here to find his gravitational potential energy when he's doing his air flares. To find gravitational potential energy, we'll need 3 things. We'll need his height, we'll need the acceleration due to gravity, and we'll need his mass. Clover's height is average for a high school aged male, 5'8", or 1.7272 meters. The height we'll be using is the length of his arms, since that is keeping him off the ground though. To find the length of his arms, we find that it is approximately 3/8 of your height. So we take 1.7272 times 3/8 and we find that his arm length is 0.6477 meters. Now when he is at the apex of his air flare, he will be about this height above the ground. The force of gravity we know is 9.8 meters per second squared, and the mass of a person his height and build will be about 66 kilograms. We'll multiply these 3 pieces of information together and we find that his gravitational potential energy is 418.93 joules. Find his landing velocity now. We take this amount, multiplied by 2, and then divided by our mass of 66 kilograms. We then square root the entire thing to find that our velocity is 3.563 meters per second. Another big physics concept used in b-boying is moment of inertia. Moment of inertia determines the torque needed for desired angular acceleration about a rotational axis. Let's now look at a video of B-Boy D-Trix doing a headspin. When D-Trix does a headspin, he can change the speed of which he spins by tucking his arms in. This relates to the conservation of angular momentum. As the moment of inertia gets smaller, angular velocity must increase so that angular momentum remains constant. Therefore, to obtain a faster headspin, a B-Boy must tuck his arms in, and to slow down the headspin, he can bring his arms out. Let's look again in slower motion to see fully how this works. The last thing we're going to look at is how angular momentum affects B-Boy pocket over here. Angular momentum is equal to moment of inertia times angular velocity. Now, to find angular velocity, we'll take his revolutions per minute, which is like Seco, 120 RPM. Now we multiply that by 2 pi to find our radians per minute. We then divide this amount by 60 to find our radians per second. Pocket's angular velocity is 12.566 radians per second. To find moment of inertia, we'll need to find his radius and his mass. Pocket is a shorter guy and his height is about 5'2" or 1.57 meters. But to find his radius, we'll just take half of his height. That is from his crotch area to the end of his foot. This is about 0.7874 meters. The mass of a guy his height and build will be about 61 kilograms. Now we multiply our radius squared times our mass and our velocity to find our angular momentum to be 475.259 kilograms meters squared per second. Physics plays a huge role in b-boying, as if we didn't have it, then we would not have one of the most fun forms of street dance. Hopefully this video helped you appreciate how your local dancer is not just a dancer, but also a physicist. Peace!